So let's get right into it. The world of AI today, it's a land of giants. We're talking about these enormous data-guzzling models that have totally rewritten the rules. But what if there's another way? We're going to look at a really cool new approach coming out of Singapore that might just prove that when it comes to AI, brains can actually beat brute force.
And just to give you a sense of the scale here, look at this number. Models like GPT-4 have over 175 billion parameters. You can think of parameters as all the little dials the AI gets to tune while it's learning. And for a long time, the philosophy has been really simple. Just add more data, add more parameters, and poof, you get more intelligence.
And that right there leads us to the big question, doesn't it? Is this relentless push for bigger and bigger models the only way forward? Or could a smarter, more elegant design get you the same or maybe even better results with just a tiny fraction of the resources?
Well, enter our challenger. It comes from a startup in Singapore called Sapient Intelligence, and it's built on a completely different idea. Instead of just trying to build bigger, they looked inward, at the very architecture of the human brain itself.
What they came up with is called the Hierarchical Reasoning Model, or HRM for short. And you know what? The name really says it all. This is an architecture that isn't about raw size, it's all about structure. A structure that's meant to copy the layered, hierarchical way that we humans think and solve problems.
See, here's the thing about our brains. We don't just use one giant process for every single thought. We've got that fast, almost instant gut reaction system, you know? And then we have a much slower, more careful system for deliberate planning. The HRM is basically an attempt to build that two-speed thinking right into the code.
Okay, and this is where it gets really, really cool. This whole thinking in layers idea isn't just a neat concept, it's the model's secret weapon. It's what gives it this massive edge in efficiency. So let's break down how it actually works. So the HRM is split into two main parts. First, you've got the planner. This is the high-level module. It thinks slow, it thinks abstractly, and it figures out the big picture strategy. Then you have the executor. This is the low-level module that moves fast, handling all the nitty-gritty details to actually carry out the plan. It's like having a brilliant strategist and a perfect soldier working together in absolute sync.
The magic is really in how they talk to each other. It's this constant feedback loop. The planner says, okay, here's the goal. The executor takes a step. Then the planner checks in, like, all right, did that help? Are we getting closer? And based on that feedback, the executor takes the next logical step. It's this back and forth that lets it solve really complex problems without wasting any time.
And what's the result of this super elegant design? It can figure out tricky step-by-step reasoning problems in what's called a single forward pass. There's no need for those long, rambling chains of thought you see with other AIs. It's just direct, efficient, and straight to the point.
All right, so the theory sounds great, but does it actually hold up in practice? Well, this is the moment of truth. Let's see what happens when this little lightweight contender steps into the ring with the heavyweight champions of the AI world.
And honestly, the results are kind of mind-blowing. When you put it to the test on notoriously hard reasoning puzzles, we're talking things like extreme Sudoku, the HRM gets incredibly high accuracy. I mean, look at this. It's not just kind of keeping up with the giant models, it's performing right there with them.
And this is the part that just seems to break your brain a little. How is it possible? A tiny model matching a giant one? Well, the answer isn't in what it does, but in what it doesn't need. The numbers here, they tell the whole story.
First off, the size. The hierarchical reasoning model has just 27 million parameters. Remember that 175 billion figure from the start? Yeah, this isn't even in the same sport, let alone the same ballpark. It's a completely different kind of beast.
And if you thought that was crazy, get ready for this. This is how much data it needs to learn. While the big models are trained on literally trillions of words from pretty much the entire internet, HRM can learn to do what it does after seeing only about 1,000 examples. 1,000. It's just wild.
Let's just put that side by side for a second so it can really sink in. This isn't just a small improvement. We are talking about orders and orders of magnitude more efficient in both the size of the model and the data it needs. It is the absolute definition of a David versus Goliath story playing out in AI.
So, what on earth does all this mean for the future of AI? Because this isn't just some neat little academic experiment. The potential implications here are, well, they're huge. First of all, it's this amazing proof that a clever design can be just as good, if not better, than pure brute force scale. That means we could train powerful AI models way faster and cheaper, and with a much smaller carbon footprint. And maybe the most exciting part?
This could open the door for genuinely smart AI to run right on our local devices, your phone, your car, without needing a constant connection to some giant server in the cloud. Okay, but let's be real for a second. The HRM is still pretty new. It has absolutely crushed it on abstract, logical puzzles. But it hasn't really been tested on the messy, unpredictable world of human language, or creative writing, or even robotics. How this beautiful, elegant structure will handle the chaos of the real world, that's still a massive open question.
And that leaves us with this one final thought to chew on. The current AI explosion has pretty much been all about building bigger models, throwing more data at them, and just seeing what kind of smarts pop out. But HRM suggests a totally different path, one where intelligence is carefully designed with these elegant brain-inspired structures. Which of those paths is going to define the next decade of AI? Well, that's the billion-dollar question, isn't it?